which we have been discussing before, the time response specifications, where we have seen this graph where you have the response of the second order system, and you can see that all the signals, whatever is being starting, it starts from 0, and then slowly it will be converging towards the uh, 1. Okay, so that is what you can see. You also have seen the overshoot, that is what the maximum value it comes in this signal, and it has also the TR, that is rise time, and you have peak time and overshoot and settling time, ESS error. So all these things we'll be discussing much in detail. So also you have seen that the values like 0 0.98, 0 0.9 and 0 0.1. So between you have rise time between 10% to 90% of the maximum value. So all these things were discussed in the previous class, as well as we have written few equations with respect to TR. Also, we have written the equations for C of t, and we have simplified it, and finally we arrived at the equation for TR as pi minus pi divided by omega and root of 1 minus zeta square. So all of you have completed till this. After that, we have to start with the peak time. So peak time TP is also discussed, where we have written the equation, the same equation of C of t. So I want all of you to study this equation of C of t for a second order system. So this equation of C of t is required for you for most of the derivations. So you need to study this C of t as well as the equation for phi. So both these equations we have used here, and we have done the differentiation for C of t. So when we did the differentiation for C of t, we got dC of t by dt, and where we are writing it as t is equal to Tp. So when wherever t is there, we have replaced it as Tp, and then we have equated to 0. So all of you have done this differentiation, and you have equated to 0. Whether we have stopped here or still we continued further, I think here we have stopped. We have stopped at this triangle or further. Okay, I think we have been in this.
This triangle, sir.
Yeah. So from there onwards, we'll continue for today's class. So I think it is clear for all of you till this minus root of 1 minus zeta square cos of omega and root of 1 minus zeta square Tp plus phi plus zeta sine omega and root of 1 minus zeta square Tp plus phi is equal to 0. Is that clear for everyone till there? Is it clear
Yes, sir.
for all of you? Okay. So you need to see, not only Sai, I want response from everyone. So you can keep responding, and feel free to respond. You are just saying you understood, or you have any doubts, that's it. So it will be clear for us further. So, I'm very much thankful to Sai and a few students. Sai is continuously responding. So others also should respond. Okay, that should be your spirit. So we are going to see that damping ratio using the triangle. So we have this triangle where we have already drawn this triangle before. So the same triangle we are using it. If you remember, these things we have drawn in somewhere in this class. So where we have seen the right angle triangle and zeta, root of 1 minus zeta and all. So same thing we are using it here. So we are using the same thing, zeta and root of 1 minus zeta and 1. And you know that from this you can write the equation for sine phi. So sine phi can be written as root of 1 minus zeta square, and cos phi can be written as zeta. So we have completed all these things till here. So I have asked you to substitute equation 2 and equation 3 in equation 1. So what you have to do here is you need to substitute equation 3 and equation 2 in equation 1. So let us substitute sine phi is equal to root of 1 minus zeta square. So 1 minus zeta square, here it is there. Here you can see 1 minus zeta square. So it will be replaced by sine phi. So this term I am going to replace by sine phi, and you have zeta as well. This term I am going to replace by cos phi. So you can see that you have this equation. So I have told you few things like you need to solve more number of problems and you can post it as well. So I am not seeing any response from your side, so much of response, but you need to do that in order to make the things clear for you. So and one more thing, that assignments I think another 10 students have to submit. So yeah, today you can complete it and submit it off. Don't make me to say again and again, because it's all available. You need to do that. Okay. So we have been substituting equation 2 and 3. We got this equation, that is, we replace root of 1 minus zeta square as sine phi and zeta as cos phi. So we got minus cos sine phi cos omega and root of 1 minus zeta square tp plus phi, plus cos phi sine omega and root of 1 minus zeta square tp plus phi is equal to 0. So this is what we are going to get when we substitute it. Now this is of the form sine A cos B minus cos A sine B. So we can write it as sine A minus B. Also, it's a trigonometric relationship which you are very much familiar with. So I am going to replace sine A cos B minus cos A sine B as sine A minus B. So further you can do it. So here, few things what you have to understand is A is equal to omega and root of 1 minus zeta square Tp plus phi, and B is phi. So what you get further is you can just substitute those things. You get the sign of A plus B. So A and B is known to you. So you'll be getting omega and root of 1 minus zeta square Tp minus plus phi minus sine phi. So plus phi minus sine phi gets removed. That is equal to 0. You will get, so root. So what you get here is sine of omega and root of 1 minus zeta square Tp is equal to 0. So you know that sine of an angle is equal to 0 only when it is equal to n pi, and it should be multiple of n pi. So we can just say that let n is equal to 1. So Tp can be written by using this equation. That is very important to understand this. Tp can be written as pi divided by omega and root of 1 minus zeta square. That will be in seconds. So this is the equation for the peak time what we have been discussing. So this C of t we have taken, phi we already know, C of t we know. We have done the differentiation with respect to t, substituted t is equal to Tp and equated to 0, and then taken the triangle and found the equation for sine phi and cos phi, substituted root of 1 minus zeta square as sine phi and zeta as cos phi, then use the trigonometric relation of sine A of cos B minus cos A sine B is equal to sine A minus B, where A is omega and root of 1 minus zeta square Tp plus phi and B is phi. So we all solved that sine of this plus phi and minus phi is equal to 0. Then omega and root of 1 minus zeta square Tp is equal to n pi. So from this we got Tp is equal to pi divided by omega and root of 1 minus zeta square. This equation is very important. So I will just start from here. You can just complete these things. You can write down these things and we'll move on further with the next term. Once you have completed, you just tell me. I will move further. So once you complete it, just let me know that.
Yes, sir,
Okay.
completed.
Okay. So further we will go with that equation. So you will get the equation for TP. So all of you write the equation for TP. So all of you write the equation for TP. Then we will go with the maximum overshoot. So have you completed? We'll proceed with maximum overshoot.
Yes, sir.
Okay. So we have got the equation for TP as pi divided by omega and root of 1 minus theta square. Now we will continue with maximum overshoot, that is called as MP. It is also called as uh, peak overshoot. So as you have already studied the from the figure, this figure is very important, and I have told you that you have to understand this clearly. So in this figure, you can see that this portion is called as the maximum overshoot, and it is denoted as MP. And so it is where you are getting the maximum peak. So this is called as the overshoot MP. So we are going to discuss that portion, and we will see how the equation for MP can be defined further. So you can just note down the third one, that is called as the maximum overshoot MP or peak overshoot. So maximum overshoot, MP or peak overshoot. So MP is explained as C of TP. Just see the figure once again. C of TP minus C of infinity divided by C of infinity. So the amount of step response overshoots the steady state value or final value at the peak time expressed in percentage. So that is what maximum overshoot indicates. So that is this one. Maximum overshoot is CTP minus C infinity by infinity. So I can just take you there and just say that C infinity is here, this line. C infinity, you can see that this line where you can see here it is C infinity, and this is also there where you are getting the maximum value. So you can see that the equation can be written as C of Tp minus C of infinity divided by C of infinity. So a maximum overshoot is the amount of step response or the overshoot of a steady state value or final value at the peak time expressed in percentage of steady state value. So that is what uh, we can understand. It is also called as the peak overshoot. So this is what you can see. So when the second order underdamped system is excited, the by the step, this steady state value is 1 volt. So we will be seeing those things when the second order system is underdamped system. You know that you have seen underdamped, undamped, critically damped, overdamped, and all those things. If the second order system is underdamped system and is executed by a step response of 1 volt, then we can say that the steady state voltage value will be 1 volt. So here the important thing is you need to write the equation for MP where it is CTP minus C infinity divided by C of infinity, and it's also called as the peak overshoot. So you can see that they may ask you in the question paper sometimes maximum overshoot, or they may ask you peak overshoot. So you have to write the same thing. So we have not completed it. We have still few equations to calculate MP, and we'll see those things further. You complete it first. So these are some of the time response specifications for second order system. So usually the entire thing is asked for almost 10 marks, or they go with the problems. We'll be seeing the problems as well, where you'll be using these equations to solve, find out all this maximum overshoot and peak response, everything. So you have seen the equation for TP as well. Now similarly we'll be doing it for MP. So if you have completed, we'll move on further.
Yes, sir.
Okay. So we have understood that it has to be C of TP minus C of infinity by C of infinity. So we'll see, and we have also understood that when the second order underdamped system is excited by a step response of 1 volt, means you're having a step response, you're taking it as 1 volt, then the steady state value also will be 1 volt. So we'll see further with a few more equations for maximum overshoot or peak overshoot. We'll see that in the next portion. So all these things comes under the time response specification of second order system. You should remember that what is the equation for C of t, what is the equation for phi, what is the block diagram for a second order system, what do you mean by characteristic equation for a second order system. So all these things I have been explaining you in the previous 2 classes. So there you can understand that we have discussed about the transfer function of a second order system, characteristic equation of a second order system, as well as C of t of second order system. Then we have also studied phi, what is the equation for phi, and by using all these equations we are doing the time response specification for second order system. So you need to start studying all these things together along with my class, so it will be easy for you to understand. If anything is there to be discussed, we will discuss it further. You can ask any doubts are there, we can discuss it. So we are going to see here that MP is equal to CTP minus 1. Why we have taken it? I have written the statement here. You can see that the step of 1 volt and the steady state value is also 1 volt. So what I can say is MP can be rewritten as C of t minus 1. So that's what I have done here. MP is written as C of TP minus 1. So it's clear for you. So MP, how it came CTP minus
Yes,
1?
sir.
Okay. So so we got MP as CTP minus 1. So we are saying that T is equal to TP. So MP is just written as C of T minus 1 itself, but we are saying that T is equal to TP. So what is T is equal to TP? We have already seen that T is, what is TP? What is TP? That is peak time. So TP is peak time. So in the previous thing, we have seen that Tp is equal to pi divided by omega and root of 1 minus zeta square. So we are just saying that T will be equal to Tp, and so this is the condition. Okay, it's not divided by and all, it is condition for C of T, that T is equal to Tp then minus 1. So what you can have MP as C of T. What is C of T? What is C of T? One of you can just say the equation for C of T for second order system. What is C of T for second order system? See, one of you can say what is the equation for second order system C of T? Yeah, you respond to that. We have written so many times the equation for C of T. Many times. I have told you these are the. Yeah, C of T we have written it. What is that equation for C of T? How many times we have written C of T in the previous derivation as well? See here, we have written C of T here. We have written C of T here. We have written here as well C of T. We have written in the previous derivation also C of T. So everywhere C of T is available. So what is the equation for C of T? See here also, that is for overdamped case. We are doing for not overdamped case. So what is C of T here? 1 minus e to the power of
minus
zeta omega and t. It is t in the equation for C of T, but we have replaced t as Tp, and yeah, root of 1 minus zeta square sine omega and root of 1 minus zeta square. T, instead of t, you should write it as Tp plus phi minus 1. See, this is the same equation which you have studied before. So that's the reason I'm saying you need to study these equations, whatever you have. We have derived this equation in the previous class. So you might have seen that here. So you can see here this was the equation derived in the previous class for C of T. So the same equation we are using it, instead of T we are going to write it as Tp. So please go through these equations, and once you study, it will be clear for you. So I have substituted C of T here. So you write down there one statement, substitute C of T and replace T as Tp. You can just note down here. So I have substituted C of T, and then it is minus 1 is also available here. So I have put minus 1 here. So I have put C of T here. This complete term is C of T, and then minus 1. So what is this this term? This is C of T and minus 1. So what you will get, is that clear for all of you?
Yes, sir.
Yes, sir.
Okay, fine. So further, we will continue further. We have found the equation for Tp. In the previous derivation here, Tp is there. Just before now today's class starting, I had done that itself to finding out the equation for Tp. This is what just now we completed the equation for Tp. Try to use this there. Now we are going to use it here. So instead of Tp, substitute that, we'll see that. So here Tp is there, here Tp is there. So what is the equation for Tp is this one. Tp is equal to pi divided by omega and root of 1 minus zeta square. So substitute that there. So you are going to substitute this Tp in this equation. Substitute there. So substitute and write the equation for MP. So I have substituted and further simplified. So substituting Tp is equal to pi divided by omega and root of 1 minus zeta square, we'll get Mp is equal to e to the power of minus zeta omega and pi by omega and root of 1 minus zeta square by root of 1 minus zeta square. Sine of Tp gets substituted there. So omega and root of 1 minus zeta square divided by pi by omega and root of 1 minus zeta square plus pi. So sine of this complete term is written as phi. So we will get in this form, Mp is equal to e to the power of this divided by root of 1 minus zeta square sine phi we will write. It gets cancelled and you will get sine phi. Sine pi plus phi can be written as sine phi. So have you all understood till here?
Yes, sir.
Substitute and do it till there. After that we'll continue. 1 minute you do that till there. You write it all those steps. Is that completed?
Yes, sir.
Okay. So all of you completed till that equation for MP. After that we'll still further simplify it and write the equation for MP. Okay, we will continue further.
Yes, sir.
Yes,
Okay.
sir.
Okay, fine. So we have seen that MP is equal to e to the power of minus pi zeta by root of 1 minus zeta square, root of 1 minus zeta square divided by 1 minus root, zeta square sine phi. So after doing that, you can say that we know that in so many times we have written the equation for sine phi even in the previous derivation as well. So you know that sine phi is root of 1 minus zeta square. So either you can substitute sine phi as root of 1 minus zeta square or inverse of that. So we are going to use this equation too, and we are going to just simplify it further. So we can see that sine phi is equal to root of 1 minus zeta square. So I am just going to replace sine phi as 1 minus root of 1 minus zeta square. So you can substitute and cancel the terms. So finally, you will be ending up with the equation for MP, that is the maximum overshoot, as e to the power of minus uh, pi zeta divided by root of 1 minus zeta square. So this is what you will get. So the overshoot MP is a function of only the zeta, that is called as a damping ratio, and MP versus zeta curve is what you can see. So that curve is which will look like this. So first you complete this equation, then I will discuss with that curve. So this equation, you should put it in square brackets for MP. This is very important for problems as well. So this is what you're going to get. MP is equal to e to the power of minus pi zeta divided by root of 1 minus zeta square. And you know that it is only depending on the value zeta. So you got the equation for MP, and now we will see the overshoot MP as a function of damping ratios zeta. So we get the curve in this form. So we get the curve in this form. You can draw this curve, and you know that MP is going to vary as per the value of zeta. So the curve is going to be in this form. So as zeta value increases, the MP will be going to be lesser. Once you complete the maximum overshoot equation and the graph, we will just proceed with the settling time. It is denoted as TS. So settling time, I think all of you might have completed. We will proceed further with the settling time. Settling time is denoted as TS, and we will see that. So TS, you can see that it settling the name itself. It is very clear that the system has to settle down, and it has to settle down to the maximum value. So what that 2% of cutoff, like you are in 98 and 100, that 98 to 100, that 2% of cutoff, the system will be there for a few seconds, and then it will settle down further. So the time required for the transient damped oscillation to reach and stay within that 2% of the steady state value. So I should just explain you this with the figure. I will take you to the figure. So this is that 2%, that small percentage of that 2%, what you can see, that 2% difference, it can be 1.02 and 0.98. So it is between these two lines. So these two lines, the system slowly will come to the stable state. So the system will be, you can see that it is coming in this form and then settling down further, and it will move further to be a stable state. So it is going to be that. So so this is what we are going to see now with the equations and all. Few equations we'll study. Its settling time is the time required for the transient damped oscillations to reach and stay within 2% of the steady state value. So the second order damped system with closed loop damping constant zeta omega n, we will see, we'll use the same equation of C of t. And so you can see that we are writing the C of t almost 5 to 6 times in the same derivation. In the same thing, we have written C of t almost 5 times. So you should know the importance of C of t. Never make a mistake in writing C of t. At least practice 2-3 times the equation 1 minus e to the power of minus zeta omega n t divided by root of 1 minus zeta square sine of omega d t plus phi. So we will see that the settling time, you can just write down the definition for that. The time required for the transient damped oscillation to reach and stay within 2% of the steady state value. This is important. The second order underdamped system with closed loop damping constant is zeta omega n, and C of t is already non-equation to you. It's not a new one. C of t, we are using the same C of t for the second order system, so which we have studied in the previous derivation, 1 minus this term sine of this omega dt plus phi. So we are going to see that how this settling time can be calculated, because it is plus or minus 2% of the steady state value. So settling time occurs approximately when e to the power of this term, e to the power of zeta omega and t, or here instead of t we are going to use ts. So this, instead of t we are going to replace this t as ts. Should be less than 0.02, because we are gone with the percentage that it will be within 2% of the final value. So it can be plus 2% or minus 2%. So we are taking it as so a settling time occurs approximately when e to the power of this term should be less than 0.02. And then we are going to take here I have done the simplification for that. Take the logarithm of that, so it is minus zeta omega n ts is equal to log 0.02 to the base e. So log of 0.02 is 4, and we have also written that zeta, so we'll get zeta omega and ts is approximately equal to 4. So till here you complete. So what you get here is, so when you take it, ts is equal to 4 divided by zeta omega n. So that's what we have told, the second order underdamped system with closed loop damping constant zeta omega n. So your ts is going to depend on the function zeta omega n. So when the value changes, your settling time also, you can see that how much time it takes for the system to get settled down within that plus or minus 2% of the uh, steady state value. So that you can just note down this, write down the definition. We'll come back to the final equation for TS. This is the final equation for TS. So all this, so here what all things you need to remember here is the equation of C of t, equation of phi. You need to remember each parameter like TPTS, all this MP, all these equations you need to find, means study. You have to by heart it off. You need to study those equations, not for the derivations, but for the problems. We are going to solve the problem, so these equations will be required there. So you need to study all these equations properly. So here we have just used the equation of C of t, and by taking the condition of plus or minus 2, we have equated that e to the power of minus zeta omega and t of s is less than 0.02. Taking logarithm, we got this, and we wrote the equation for t of s. So all of you complete it. So one more term we need to study, that is delay time. So once you complete the settling time, we'll move on to the delay time. So put this in square brackets. This is very important. So we'll go with the study. So we have already understood the settling time. All of you have completed settling time. So
Yes,
this
sir.
part also you have completed. So
Yes,
all of you
sir.
have complete. Okay, fine. So we'll just see this delay time, the last one. So the delay time, once you understand, then we can move on to the problems where we use all this TS, TD, and all these things further. So delay time is represented as TD, is defined as a time taken for the step response to reach 50% of the final value from t is equal to 0. So if you see that in the figure, you can just see that it has to reach to the 50% of the maximum value. So somewhere here. So somewhere here, 50% it has to reach. So that we are going to see that how much time it takes for that to reach to that point. So we will see that. So delay time, you can write down this delay time is the TD is defined as the time taken for the step response to reach 50% of the final value from t is equal to 0. The delay time is obtained by setting C of t is equal to 0.5 and solving the equation solving for t. So there is no much things to be done here. So here we are directly writing the equation for TD. You can just write the equation for TD. We are not deriving here delay time or in this. So we got the equation for TD as 1.1 plus 0.125 zeta plus 0.469 zeta square by omega n. Zeta is between 0 and 1. So this is we are writing the equation for delay time as well. So the time taken by the step response to reach 50% of the final value is called as delay time TD. So you can write down the definition for that as well. Now we have studied all these terms. Now we are going to use this in equations and we are going to solve it. So once you complete it, just let me know. Is that over?
Yes, sir. Oh, sir.
Okay. So this is what we have seen about delay time, settling time. Then we have seen this one peak time. Then we have also seen maximum overshoot, all those things. So we will go further. So we have to solve this problem. So once I will just brief you out these things and then we will move on to the problem. Okay. We'll do that problem in most probably in the next class. I'll just explain you the time response. So what just in 2 minutes, I'll just explain you. You can just go through this. So time response specifications we have studied. The first one is the rise time. So where we have used the equation for C of t and then simplified it, and we received the equation for the time response that is given as the rise time, that is given as TR is equal to pi minus phi divided by omega and root of 1 minus zeta square. This was the first equation we got for TR, and then next we completed the next one, that is peak time TP. So there also we have taken the equation for C of t as well as phi, substituted it, took the differentiation of that and equated to 0, and then substituted 1, 2 and 3 in equation 1, and finally used the trigonometric relationships, and then you got Tp is equal to pi divided by omega and root of 1 minus theta square. You need to remember all these equations. I am just briefing you because we are going to solve the problems further. Then we have done with the maximum overshoot or peak overshoot. It is denoted as MP. You got this equation, and then we have written the equation for MP, and we wrote MP in terms of C of t minus 1, and then we substituted C of t, then simplified, got the equation for MP as e to the power of minus pi zeta by root of 1 minus zeta square. Then we did settling time. It is denoted as TS. We got TS is equal to 4 divided by zeta omega n, and we just completed the delay time, that is TD, and we got TD equation as well. So we will stop it for today. We will complete the problem in the next class. So any doubts or anything you would like to discuss, you can just let me know that. Is it clear for everyone?
Yes, sir.
Okay.
Yes,
So we
sir.
will.
Yes, sir.
Okay. Okay, then we'll stop it here, and we'll solve the numericals in the next class.
Thank you, sir.